Okay, so structure charts. Basically, a structure chart is intended to describe the components of a software system and how they relate to one another. Usually they're arranged in some form of a hierarchical outline or hierarchical format that implies sequence, meaning the order of invocation. One method is called before another, one module is called before another, etc. Selection, meaning there are conditions for invocation. This thing has to happen before that thing, for example, or we need to be able to have access to some other module to provide our output to it as an input. And iteration, so you would be able to see which modules are repeated and the conditions under which they are invoked in repetition. Normally, you're going to read a structure chart from top to bottom, left to right, and there'll be numbering that implies the levels on which you need to read them. I say normally because as we get down into some of the more interesting architectures, it may not be possible to read top to bottom, left to right, but when we get there, you'll see sort of why and how you'd want to read them in those circumstances. Okay, so structure charts can, but do not have to, outline part of a system, a component within a system, or an entire small program. Sometimes, depending on the size of the program, you could show an entire program. It may actually be possible to do that all in one structure chart, but sometimes it's not, and you would end up having some hierarchical relationship between the structure charts, not dissimilar from what you would do with a level 0 data flow diagram versus level 1, and so on down the road. You can show the thread of control for a whole system. You don't have to, but you can show the thread of control for a whole system, even when you have hierarchical multiple structure charts showing the entire system. And you can use this to break the system into modules. Structure charts are very good at breaking a system into modules and helping you to reason about what the modules are and what order they should take place in. You can also use this to show both data and processes, but there's more emphasis on processes, right? So in a data flow diagram, you're really interested in showing where the data flows, right? It's all about the data. But they also have processes as well, and how the processes relate to one another is important, and it's a critical component in doing refinement of a data flow diagram to create a child diagram for a data flow diagram. But you could say fairly that a data flow diagram is really more interested in the data than the processes, because the data is actually the central piece of a data flow diagram. Where the data goes, how it is stored, and how it's processed is all central to data flow diagrams. The same sort of thing is true slightly in reverse with structure charts. We want both data and processes, but the emphasis here is more on process. So you aren't as concerned about the particulars of the data. You are much more concerned on the processes and how this affects modularity and architecture in a structure chart. All right, so here is an example structure chart. And just reading this again, top to bottom, left to right, you'll see sort of the flow of the program. We start here in the top, the first process here, where we're producing a class roster. Once we have produced this initial request, we'll get the course number to figure out what class it is we need the roster for. The course number is returned using what we are now introduced to as a data couple. Okay, so this arrow is representing the flow of control, and this open-ended arrow that is disconnected from these processes is actually representing a data couple. An open-ended arrow, like the one we see here, represents the data couple. A closed-ended arrow, on the other hand, like we have here for this end of file, represents a control couple. Okay, so this is a control message, essentially an indicator that as we are looking at the course number, if there is no course number, maybe we've gone through the file where all of the course numbers are stored, we have an end of file control indicating, well, there's no course number, it's just we've reached the end of the file. So from this process, we're expecting to get either a course number or an end of file indicator control couple. After we have that, we can take the course number and send it down to the search for course listings for cross-listed courses, and we may be returned another data couple in the cross listings that are found from that course. Now, of course, we could do another end-of-file list, assuming this is another file of cross-listed courses. We could have another control couple that is not modeled here. That could be a design mistake, but it is not necessarily a mistake in the use of structure chart primitives, right? So it's a design decision not to include an end-to-file marker, but there may be some other reason for that. This is sort of an open-ended question and the kind of thing that you may want to address in the text describing and walking through the structure chart. In this particular case, we're just trying to make a simple example that would fit on one slide without having too much going on. Okay, so this curved arrow here represents iteration. So after we finish this search for cross-listed courses, we move on to the next process that originates inside of this curved arrow, which is searching the student database to get a list of students in that course, right? Because we're trying to produce a class roster. And once we have that student list, we may need to go back and get the next cross-listed course, right? So we could iterate through the search for cross-listed courses, get a student database, search for cross-listed courses, get a student from the database or a student list from the database, and so on until we've gone through all of the cross-listed courses. And again, you could have control couples that indicate when to stop this process if you want. But once we've completed all of this, this searching for cross-listed students, we would have a complete list of all of the students, and we can pass the course numbers, meaning all of the courses, including the cross-listed courses, plus the student list to the display procedure that would actually display the course roster. So top to bottom, left to right, we're reading through the structure chart, and we should be able to see how this would actually result in producing a displayed course roster for the course registration system that we're talking about. There are many other examples in the textbook, and I strongly encourage you to look through them, but this is, I think, the simplest example that we can go through related to the sort of running examples that we've had in this course. And there are things from a design perspective you could do to improve it. Again, I think maybe including additional control couples and that indicate when and how to move on through the rest of this process would be a good way to add that. And in fact, one of the exercises that I had in an earlier version of this class is to actually add additional control couples and describe what they mean and how they would affect the processing of this particular structure chart. It's not a bad exercise to go through on your own. Okay, so let's talk a little bit more about how you would do this top to bottom, left to right reading, and how you could create textual descriptions that describe what's going on in the structure chart. This is a simplified structure chart in the sense that it doesn't include either control couples or data couples. Okay, so we're really only interested in talking about the control flow of a structure chart. And there's two different ways that you could do this, two both equally valid approaches to describing control flow in a structure chart. I'm walking you through this in part because as you see textual descriptions of these, or maybe all you have is a textual description. You're trying to create in your mind a structure chart that describes the control flow. You can read them either way. Either is valid. So in the first description, control starts in module A and then passes to module B, and from B it passes to C. When C is done, control is returned back to B and then back to A. At this point, control passes down to module B, which passes it back to A, and then we finished. Again, we're doing top to bottom, left to right. Okay, that's the way you would typically read a control flow in a structure chart. Now, you could also, a totally valid way of reading it, read this as module A calling module B, which in turn calls module C, and then C returns to B, which returns to A. Right? So instead of focusing on control, right, the actual thread of control, we're just focusing on modules calling one another. This is more of an object-oriented approach. When control eventually gets back to A could call D, which would return to A, and then A finishes. So the same process, the same outline, but instead of focusing on the thread of control in sort of a functional approach, which is this first description, we have a module calling module, which is more of an object-oriented description in the second textual block. And so a structure chart can work in either functional systems or object-oriented systems. Typically, the only difference is which of these two descriptions do you use when describing. So here's a somewhat more detailed structure chart that actually includes the data couples and the control couples. And you can actually see how this might affect the textual description at the bottom here. So again, a data couple is the one that represents data being passed with an open-ended arrow, and a control couple represents some kind of control information or control signal that's being passed from one module to another, not a data item. It's just a control signal. Okay, so here's the textual description. Module A is passing X to B. So this is sort of an object-oriented description because you can see the focus is on modules passing things rather than on where is the thread of control going. And then B passes X again to C. C creates Y, which is this information signal, this control couple, and passes that back to B, which then creates Z. Notice that Z was not created by C. It's just created by B in response to this signal returning from C. And then Z is passed to A. A can take Z and pass Z to D, right? And then D would return to A by not passing any information, whether it's a data couple or a control couple, and A would finish the program, right? That is a valid reading of control flow in this structure chart. So how do we actually create structure charts? Well, if we're starting with a set of DFDs, which is sort of the basis of this course and the process that we're teaching you how to build information systems using this course, you can create tiers of a structure chart according to the levels of your DFD. So for every module in a DFD process, you'd start with a module for every DFD process and then leave out all of the totally manual pieces. So anytime you're interfacing with an external entity that is not an automated server, you'd have to leave that part out. Then you can rearrange and combine modules to facilitate a flow that makes sense for processing. Normally this would involve identifying the data couples and control couples roughly at this part, because this is where you're going to see what is needed to be move on to the next piece of the control flow. Typically, you'd want to add details only where they're appropriate. In a DFD, you're probably going to have a lot more information, but we're trying not to emphasize all of the data so much as we are the order of processing, the thread of control in a structure chart. We want to understand what does the architecture look like with a structure chart rather than how do we actually process all of the data. And from there, you can fine-tune things to make sure that when someone looks at the structure chart and starts reading the structure chart, they're able to get a sense of the flow of control and the high-level modularity of the system, since that is actually the purpose. And again, normally there would be a somewhat extended activity where we would go through and create a structure chart for the course registration DFD that we've been using in this course. I think it's not a bad exercise to do this on your own. The challenge there is I need to be able to give you feedback to show you where things may work and where things may not work. But that's the goal of the exercise. So normally this would take, usually I'd give about 5 minutes before I start walking around, and then I'd spend a couple of minutes with each of the groups kind of going through what works and what doesn't. So it ends up taking 20-25 minutes as an exercise in class to go through this. And I do take this very seriously because creating a structure chart for something like the course registration system is actually the kind of exam question that I would typically have asked on final exams for this class. So I don't know if we'll be doing that this semester. It'll be a little bit hard to ask something like that in Blackboard using the Respondus lockdown browser. So we will see what we're going to do. I want it to be fair, and you shouldn't really stress about it as long as you're going through and trying to create structure charts and asking honest questions about them.